So we can start with a very short introduction about us. I am Lavinia Guadagnolo, product owner and data scientist at Plentitude.
I'm Alessandro. Hi everyone, also a product owner and data scientist in Plentitude.
And we are part of the MLOps, and as our team name might suggest, MLOps is quite an important topic for us. Plentitude is an international benefit company active in the energy sector since 2017. We are also active in the production of energy from renewable sources and in the area of e-mobility. We sell energy and energy-related products to over 10 million customers. Our key strategic pillars are innovation and sustainability. Now I leave the floor to Alessandro, who is going to show you our challenges.
Thanks, Lavinia. So, challenge. Plitude was born as a digital company. Of course, we use data, but not in advanced analytics. So we made our journey. When we started in 2018, I think, yes, we were just 3 data scientists and 1 data engineer trying to build the first POC and machine learning model. But you have to think that now we have 5 teams with 5-6 people each building an application and machine learning model. So we grow and we grow a lot. And this brings me to the first challenge, collaboration. We have to code, we have to work with people with different skills, with different background, with different seniority that maybe arrive later in the team and have to catch up with what was done before they arrive. So collaboration was an issue. We have to find a better way to collaborate each other. Another pillar, another challenge was the agility. As I said, we started with POC. This means that we had a lot of manual steps in our industrialization. We have a lot of bug fixing to do through the change when the teams change. Another problem that we face up was the scalability. When we start to bring value to the business, when the business understood that advanced analytics can save money, they come to us and ask many models. So we had to be able to scale up and reduce time to market deliverable of our models. The last challenge that I want to underline was the experiment. In the beginning, every data scientist has his own notebook with tests, with experiment, with setting parameter. But it was not enough when we start to put in production model. We have to be very solid in experiment, to track the experiment, to understand which were the parameter that we choose for our model. So we find, for all this challenge, we find MLOps as a valuable answer because by standardizing process, promoting automation, and encourage continuous development, allow data scientists to really focus on generating real business value instead of be blocked by operational and maintenance stuff and tasks. So tools. MLOps it has several aspects, procedure, best practice, but also tools that can help its adoption. And today we are going to talk about 2 of these tools that Databricks provide us. The first one is Unity Catalog. I won't focus on technical stuff. I'm sure that Databricks folks already educated you enough about Unity Catalog. Here we want just to underline how the Unity Catalog fits in our architecture and how help us in the MLOps application. So here you can see our free environment, the sandbox environment in which everyone, data analyst, data scientist, data engineer, ML engineer can work with data, can try whatever they want, and they are very free to do everything. Then we have the staging environment in which our industrialized code run and where we made all the tests, the final test. And then we have, of course, the production in which the stable version of the code run. I want to underline that the Unity Catalog is an architecture that crosses every environment and allowed us to use in every step of the life cycle of the model the productional data. Of course, in a controlled manner. So we can control the access to model, to data, really in deep. To do this, Unity Catalog allowed us to really have a data-centric approach to machine learning. We can, with just one tool, we can control model and data together. But of course, model and data are not the only asset that in MLOps we have to manage. We have also to do the management of the code. And now Lavinia will tell you more about this.
Thank you. Okay, so at Plentitude, we build different types of data products ranging from reports, machine learning models, tables. So the aim we are trying to achieve with our machine learning, with our data product, determines the components we need. For instance, if we are realizing a report or building a dashboard, we might need only Databricks notebook, and we might need only VM to execute our code. But if we are building a machine learning model, we might need different components. We might have dependencies in our code. We might need different execution environments for each step, from data preparation to training and inference. So we might need MLflow to track different experiments and Databricks workflows to orchestrate these different tasks. We also have to take into account that when we work on a data product, normally at least one data scientist and one data engineer work on the development of the data product. So we have to ensure safe collaboration while working. And the way we run the code depends on the environment we are working in. So complexity is quite high, and Databricks Asset Bundles is the tool which helps us to manage this complexity. Now we are going to see how. So Databricks Asset Bundles provide a way to include metadata alongside our project source files. This metadata is included in YARN file in which we specify artifact and resources. And we can use Databricks command line interface in order to deploy, validate, and run the bundles. Bundles can be created from scratch or can be created using a template. And they can be used in the development phase, but they are particularly helpful during the deployment phase as they include CI/CD capabilities during in software workflow. So let's see how Databricks Asset Bundles helped us at Plentitude. First of all, as I said at the beginning, we improved the way we collaborate. Then, for us, in some use cases, especially for GDPR reason, compliance is quite relevant. And Databricks Asset Bundles keeps a version history of the code and of the workflow. Thirdly, we set standards. So we set standards for different types of machine learning use cases, ranging from clustering to time series for forecasting. We set standard once, and so we are able to be more effective in machine learning model development. So data scientists were able to reduce the time to market and improve velocity. Now we are going to see into details how we leverage Databricks Asset Bundles. Okay, this is a high-level picture of our repository structure. It's quite general. What I want to highlight here is that we have a file named databricks.yarn file, which is the root bundle file. Then we have a folder named asset, in which we include our machine learning asset. And at the end, we have a folder which includes our files related to CI and CD configuration, which we execute on Azure DevOps. So we are going to see now into details, all of them, almost all of them. Okay, this is the first one, it's the databricks.yarn. Here we specify the bundle name, job definition, and then we define the target workspace for each stage, so development, staging, and prod. Then we are entering in the asset folder, and we have the model workflow asset.yarn. Here, we define a Databricks job, which can be scheduled and can perform different tasks orchestrating notebook execution. We then specify the task which has to be executed. So we have the first two, which are related to data preparation, which are target creation and master creation. Here we specify the notebook path and the parameters. The third task is related to model training, and here we specify the dependencies. So this task should be executed after master creation and target creation are executed. So we are going to see how this is implemented afterwards in the demo. Then we have the batch inference workflow asset, in which we specify a job cluster, which is used for performance reason. And we also specify, again, the job related to the inference task as we did before. So we specify notebook and the parameters. And yeah, we are going to see how this is managed afterwards in the demo. And now I leave the floor again to Alessandro.
Thanks. So we saw the tool. Now we are going to see the heart of MLOps, the CI/CD pipelines. So really in the high level. First of all, I want to underline that we develop our pipelines in Azure DevOps, and we choose we follow the TBD approach for manage the branching. But when you have a model in production, but you do some change in your sandbox environment, you want to bring this change through each environment until the production. What you're going to do in very high level, you create a pull request. This runs some pre-commit test. Then it starts the CI pipeline that also perform some tests and build the artifact. And in the last, there will be the continuous deployment pipeline that do the bundle validation and deploy sequentially the code to each environment. Let's see now what means CI, what means continuous integration. So you are a developer and you make some change, as we said. You push the code, it starts some pre-commit. If you do have the pre-commit, it starts some pre-commit check. Then, if this pass, there will be the continuous integration pipeline that performs some test. It's enforced check that we already did in pre-commit. There will be other tests that we'll see in the next slide. If all these tests pass, the CI build the artifact with this version. So which kind of test you can do in your CI? Here there is, for example, so you can do the static code analysis that perform testing to underline the potential defect and security vulnerability on your code. You can do the unit testing, so test the logic on your small piece of code. You can do also the integration testing, so they perform testing to all the end-to-end pipeline. And you can do also the load testing that stress your system to check the ability to handle, anticipate the workload. Normally, in our classical machine learning product, we perform the first 3 typology of test. Now, I would like to go deep in the static code analysis. Why? Because this was one of our challenge. As I said before, collaboration was a challenge that we face. Because as Lavinia said, normally on one of our model work one data scientist, one data engineer, so many people. And it's also happened that maybe a colleague arrived later. So we need to have all time a very high quality code. If to do this, we perform tests with rough and black and sonar code. Another issue was security. We try to build our model security by design. And to do this, we perform tests with Bandit and with Veracode that give us also a report in the end that we share with our cybersecurity teams team to have all time to be aligned all time with the security. Okay, after the continuous integration pipeline, there is the continuous deployment pipeline. Here you see the schema. Here in this slide, I would underline 3 things. The first thing is that in each environment, so P1 is our sandbox environment, P2 is our staging environment, and P3 is the production. We have the access in reading to the productional data. So in each step of the model, we can use the productional data in controlled way thanks to the unit catalog. Then I want to underline that we have 2 gates in which the maintainer, that it's different from the developer, it could be a senior data scientist or a senior machine learning engineer, have to give his approval to bring the code in the next environment. And then our hybrid approach to the deployment. Between P1 and P2, so sandbox environment and staging environment, we deploy code. Between staging environment, in which we perform the final training and the final testing of the model, and the production, in which there is the stable version of the code that run, we deploy models. So we choose this hybrid approach to the deploying policy. When we deploy the model in production, here we just focus on the model evaluation. So when we apply some change in the code, or our model in production have decreased its performance, we training in staging a new model. So we have the new model, we register this model in a model registry, we run validation model. It means that we check if the new model has the performance of new model are above the threshold that we set as a minimum for the particular application. Is so, we call this model challenger, and we make the comparison between its performance with the performance of the model that run in production. If again the challenger have better performance than the model in production, we deploy this model in production, and it will be the new champions. Okay, with this last slide, we would like to underline that also for large language model, you can apply MLOps. Of course, the challenges are different because you have different performance metrics, you have hyperparameter tuning that is completely different. Of course, you have issue with computer resources. You could have the human feedback inside your loop, and so there are a lot of stuff different, but the structure MLOps remain the same. And maybe we are going to talk next year about our application LLMs in our company. So now I give.
Thank you.
And we will see the demo.
Okay. I've registered it to avoid unwanted surprises, and also since I needed to speed up some parts a little bit. Okay, so now we are...
is not sure.
Oh, okay. Hold on a moment. Ok. Ma così la vedo. Ok. Okay, this is very hard. Okay, we'll start. Okay. Now I'm working on a branch named MLOps. Okay, this is my branch. I will edit a file, and then we will see how our process starts from pre-commit checks to our development phase. So let's start. Okay, here I open the README file, and I just write a line of code, which is test. Okay, so I commit, then commit my change, update it. And I can also review what I've just edited. And I want to merge my branch into the main branch. So according to the TBD approach, which Alessandro mentioned before. So once that I did my commit, the PR pipeline starts. Okay, here we can see the latest run. the one which is executing right now, and we are executing quality and unit tests. So we can see now the list of the tests which are being executed. We are installing Python dependencies. Then we will cache our the results of our tests. And all of these tests are in the pre-commit phase, as you can see below. It is highlighted. And they are cached, so when we execute the CI, during the CI, they are a bit faster. Anyway, we speed it up a little bit just to be on time. So we run the pre-commit check. After that, we run the unit test. Okay, and once that all the tests are completed, we should see our artifact. We are finalizing our job, and we also build a report to check the results of our test. We can see that the tests are completed successfully. We can also have a report about the code coverage. Then we can go to the PR. We are merging our branch into the main branch. There are no merge conflicts, so everything is fine. We will refresh the page related to the pipelines, and we can see now that the CI pipeline has started. So we can open the latest run, which is executing right now, and we can see that we are executing quality and unit testing. Okay, some of them have already been executed. When they are executed during the CI phase, they require only a few seconds, since we have the results saved. And as Alessandro said, these tests ensure that our code is of good quality. These tests are related mainly to static code analysis. Then we can publish our artifact. We can see that now we are executing the very last step of our CI pipeline. So we are caching the pipend, and then we are creating also the file for Veracode, which was the tool for scanning vulnerabilities in our code. And it also provides the report we share with our cybersecurity team we mentioned before. Then, once the job is completed, we can go back. Everything is fine. So we can see our artifact, which has just been created. And we can refresh the page now, and we'll see that the CD pipeline has started. We open the CD pipeline, we can click on the latest run, and we are now in the development environment. So we can open to see what is happening right now. So we are validating Databricks command line installation, and then we are setting authentication for credentials. After that, we can deploy the bundle and then validate the bundle. So we are leveraging Databricks command line interface. As I said, when I was talking about Databricks asset bundles, this is where they are useful. They are put in action. Then once the bundle is deployed, we can run our training workflow. So it takes a few seconds. Okay, now we can also monitor our run, since a link will show up in a few seconds. Okay, and we can copy and paste it. Okay, below you can see on my right, okay, you can see the model registered in the catalog, and you can see that version 9 is the champion model. While on the left, you can see that we have the MLflow model tracking. In this case, we are building an ensemble model which consists of different models. On MLflow, we monitor all of them and we register all of them, while on the catalog, we register the final version. So above, you can see that we have two tasks, target creation and master creation, which are the two I mentioned before, and I show them in the YARN file, and they are executed in parallel. After they are completed, model training starts, and here we speed up the video a little bit. So we will see now that a new model has been trained. So we have a new model version 10 registered, and the model is valid, validation is okay. The new model is the challenger. So now we will compare its performances with the champion model. And at the end, the version 10 is the champion. So, okay. So that was the end of our demo. Now I will try to present again. Okay, great. So, some takeaways. Cultural shift into an MLOps approach is as important as the implementation. So for us, it was a journey. It was a journey which involved different types of figures, data scientists, operations, third-party vendors. We organized a series of workshops to try to build our framework. And of course, we have some constraints that we had to take into account in developing our framework, which were related to our company policies, and all of us has this type of constraints, but they should not be considered as a limit in designing your MLOps approach and your MLOps framework. You can adapt to it, and you can build the framework which best fits your needs. And finally, MLOps is an investment. It takes time, it requires effort, and different figures have to work to build this framework. But in the short, medium term, it brings along benefit which highly compensate the effort. So before concluding, I'd like to thank our team at Plentitude and also Flavio Primo from BIP, who helped us in the designing and the development of this comprehensive framework. So thank you all for participating to this session. And if you have any questions, we are available to answer.